Okay, just a reminder that these lectures are being recorded. Sorry about the echo last week, having no sound. I don't know what that's about. The microphone's on for sure, so the echo should be recording something, although I do mirror the videos to YouTube, although you may have to watch the occasional ad. I don't have advertising unlocked on my videos, right? They're supposed to be free, but I guess we have to watch an ad because they're hosting them. That's like about the strangest thing that I have to do is watch an ad for a video that I myself uploaded to YouTube. Makes me kind of feel bad. All right. Housekeeping. Assignment 1 is due August 25th. So this Friday at 3 p.m. 3 p.m. Savvy? Some of you still haven't uploaded anything to Gradescope. I don't know if these people are people who've dropped, but please upload something to Gradescope because we need to make sure you have a Gradescope account. Remember, there's a 2-hour grace period, but I wouldn't play with that too much. But technically speaking, the assignment deadline's at 5 p.m. I'm not authorized to make decisions about administrative stuff regarding this course. Like I can't switch your practical session. I can't give you permission to enroll externally. And in particular, I don't have authorization to give anyone an extension. You have to apply for an extension through the appropriate channels. Just Google ITEE, apply for extension, and you'll get a web page where you do this application. So please don't email me. I'll just say, sorry, but you have to do it this way. The maximum extension is 1 week. We can't do anything longer than that because we need to evaluate the homework and give you guys feedback. And we also release the answers to the homework. So I can't withhold the answers to the entire class for a handful of students. If it is the case that you still can't submit after the following 1 week extension, and you also have grounds for not doing it, like a medical reason, the best I can do is a reweighting for you, but that normally doesn't work out. We're going to start grading once we received all submissions. So that's minimum, like this Friday, you have to wait minimum 1 week for us to collect all of the submissions for people who have extensions. So just be patient with us. And just a reminder that if Gradescope fails to execute on your submission, you're going to get a 0 on your functionality mark. So every year we have people who say, oh, I submitted to Gradescope. It said I got 0, but like, why did I get 0 in the end? It's like, well, you have to initially pass the Gradescope tests. The value that you're given on Gradescope for the practice tests are your minimum score. But like if you get 0, that's your score. So just be careful. You're allowed to upload to the Gradescope like an infinite number of times, right? So you really should be doing, like, you should have uploaded to Gradescope like at least a dozen times, right? By trying to solve the homework and then finding out that you've done something wrong and then redoing it. I also want to offer some encouragement to those students who found this really difficult. For people who are new to this, assignment 1 is going to be the most difficult assignment because you're going from not programming ever to programming. And that there's like a pretty significant learning curve. So for those of you who are really frustrated, I just want to say it's probably going to get easier now as we move forward because you have some sense of what like has to be done and you're going to get better at programming. And I'm just going to keep introducing sort of more tools, but the fundamentals is there. Like, again, I don't know how many times I can stress this. Having if statements and while loops and sequencing means you can do anything that we can do in computer science. So everything from this point on, in some sense, is just a little bit extra, right? So keep holding on. I know that interfacing with the tester is kind of frustrating, but like we did it on purpose for you guys to have to do string comparisons to get you used to the tester being really inflexible. So the next tester should be a little bit easier to use, but it was deliberate. The last thing I'd like to say is that struggling on your assignments is good. They say that confusion is the sweat of learning, right? So if you're confused a lot, that's good. It's the same thing as like sweating at the gym. It's how you gain competency. And in particular, practicing, like actually doing your homework, is the only way really to gain competency in programming. So every year we have people who get perfect on all the assignments who like, again, do worse than random guessing on the exam, which like indicates to me that like they probably cheated on their assignments. So don't try to maximize effort on your assignments, right? I guess what I'm trying to say is don't try to maximize effort to maximize grade outcome on your assignments. Like you really do have to learn how to program, and getting perfect at all your assignments isn't going to be sufficient to pass the course. Although it's great practice. Most of you will get most of the marks for most of the assignments. So is there any questions regarding the assessment item that's due on Friday? So better check the chat. No. Okay. So just note that the help center is still open, that you are able to access the help center remotely if you want. And then if you want to extension, yeah, please apply for one. And it's pretty trivial to get an extension. So I just want to, everyone who applies for an extension basically gets one. That's the directive I gave the administration for this course. Like if you want an extension, just Google Zoom doctor, and for $10, a Zoom doctor will certify that you had a headache or diarrhea, and then you'll get a 1 week extension, right? So if you want a 1 week extension, it's just that easy, right? So take it if you want, but be careful because the next week is already a week we've allocated for beginning assignment 2, right? So if you keep pushing it back 1 week, like I don't see the purpose of being out of phase with the course by 1 week. Okay, so last week we finished with dictionaries. So let's just recall what a dictionary was. So there's like 2 things that we have to study in computer science: how to get the computer to do stuff, and how do we actually like represent data in the computer, right? So this is the difference between a control structure and a data structure. So the control structures are things like if statements and loops, and the data structures are things like strings and lists and dictionaries. And I said dictionaries were like super important, which they are, because they're sort of this magical data structure which allows us to store everything as key value pairs, right? So instead of having like an index like 7, I can have an index like Paul, right? Or an index of a triplet. And indexing in and out of these dictionaries happens in constant time, right? So we don't have to do these types of searches. So I just want to do some of the final exercises that I wasn't able to do that day. So here's the first one. So given 2 dictionaries, D1 and D2, which are keying integers to list of integers, I want to return a dictionary where each key is a key that is both in D1 and D2. So this is sort of like the union of the 2 dictionaries. Okay, let's try this. Keep my hands warm. To move this, can we move this to the bottom? Perfect. Okay. Combine. So we want to take a dictionary, which is, oh, sorry. I want to take D1, which is a dictionary, which is taking integers to list of integers. And then I just want to duplicate this, D2. Then what was I returning? Another dictionary, which is keying integers to list of integers. And I'll just let that, well, maybe I can just do this. Okay. Line continuation. Cold. Okay, so I'm just going to grab the usage example. So more or less, we want to take two dictionaries. So here's a dictionary that was mapping 1 to the list of 2 and 4 to the list of 5, 6. And this second dictionary was mapping 4 to the list 8. And we want to get back, that seems to be their sum. Is that what I wanted? Return the dictionary where each key is a key that is both in D1 and D2. The values associated with each key is the sum. Okay. So the reason that there's a 19 there is because 4 maps to the list 5, 6, which sums to 11. And this 4 goes to 8. So 8 and 11 make 19. So let's try and do this. Okay. Maybe I'll move my terminal down so I can make this a bit bigger. Any ideas of how we can do this one? So let's think. So like the first thing I need to do is isolate which keys are the keys that are in both dictionaries. So I have two dictionaries, D1 and D2. So how can I look at every key of D1? Who recalls last week? A for loop, yeah. So I can do things like for a key in D1. Now I want to check if that key is also in D2. How do I do that? Pardon me? There's that would work, but there's a simpler way. In, yeah. If key is in D2. Right, so whenever we're walking through a dictionary or we're using in, it's always presumed that we're like walking keys or checking keys, right? So for a key in D1, if the key is in D2, then what do I need to do is create a new dictionary, right? So I usually do something like answer is an empty dictionary. So we can do something like this. That would also work, right? That's also an empty dictionary. I want to return that dictionary. So for a key in D1, if the key is also in D2, I want to do some answer. Oh, I hear people. What is happening? I want to do something like answer at key is equal to the sum of D1 at key plus the sum of D2 at key. Does that make sense? Okay, let's see if this works. P3 and box. I want to have something like this. 4 goes to 19. Okay, let's see. If I change this to a 5, if I change this one to a 5, what do we expect the output to be? None. Well, okay, not none. Empty dictionary. Right? Because that's none wouldn't actually be in our return type. But I think I get your drift. It's just that none in our language actually is something. So empty dictionary. Right. So the purpose of this example is just to say, remember, you can use for loops and you can use keys. You can use in, right? These sort of programs don't have to be overly complicated. Let's try another one. Write a function with the following contract that does a reverse lookup. Okay, so I have keys that goes to values. And what I want to do now is give a value. That shouldn't be item. That should be value. I'll change that. I want to give a value so that you tell me all the keys in the dictionary that correspond to that value. Reverse lookup. So here's a dictionary that goes 1 to Bluey, 19 to Chili, minus 31 to Bluey. And if I ask for all the keys that have mapped to Bluey, that's like a 1 and a minus 31. So here's a reverse lookup where none of the keys correspond to a value that we've given. So here we get an empty list. So let's try doing this reverse lookup. Reverse lookup. I'm going to take a dictionary. And the problem is we don't know anything about the dictionary aside from it being a dictionary. I don't know what its keys are. I don't know what its values are. So that's how we can doc hint that. I also want to give a maybe V for a value, but I don't know its type. I can't type hint it. Right? It's too generic. Right? So I'm just going to leave it like that. And then what I'm going to return is a list. And again, I don't know what the contents of that list is because the typing is too generic. We wouldn't be able to do this in other languages. This is one of the advantages of using Python, is that the variables are called polymorphic. We'll talk about this later. But the fact that, yeah, like X can be an integer, then it can be a string, then it can be a list, right? That's not allowed in other languages. So I'm just going to grab one of our, well, maybe I'll grab the usage examples. And, oh yes, it's complaining about my quotations, so I'll just fix them. Ooh. Okay, so that's what I want to get this to do. So how can I do a reverse lookup? So what are we going to have to do here? Well, we basically have to look at all of the values. And every time we look at a value, we need to know what key it was going to. So again, let's just use the for loop, right? For a key in our dictionary, if the dictionary at this key, if the value there is equal to the value that we're searching for, then we want to append this to our answer, right? What was I doing? The keys. And I want to return answer. Yes, but I should start answer from empty. Will this work? Let's take a look. Whoops. Oops. That's what I got for being lazy. 1 and minus 31. Cool. Let's try looking up muffin. Empty. Perfect. Right. So these for loops, again, are like the best language feature of Python. So be sure to use them, right? So many errors are created by doing indexing wrong, and this prevents us from having to do any indexing. Ooh, okay, what's next? Write a function which inverts the keys and items of a dictionary. Okay. So this one, invert dictionary. We're going to return a dictionary, and I want to discuss. I hear some people talking. How is that possible? Yeah. Let's try hitting this button. I think I'm unmuted. Okay, let's keep going. Okay, so here's invert. So let's come up with one usage example. Oh, here you go, Your Majesty. Okay, invert. Anyone get that Simpsons reference? No? Homer goes to a different bar because he's pissed at Moe, and the guy gives him a glass, and he's like, "This one's dirty. Can I please have a clean glass?" And the guy cleans it angry. "Here you go, Your Majesty. Your clean glass." Oh, but did you hear Matt Damon was at the ECA? So I guess I didn't meet the most popular, famous person at the ECA. It's just I'm dismayed by this. Okay, so let's say 1 goes to A, 2 goes to B, right? So the inversion of this dictionary would take A to 1 and would take B to 2. Now, the important thing for this function is going to be its precondition. What do we have to insist on here? Pardon me? Okay, yeah, so indeed. Okay, so, but we can think our ways around it. But for the time being, we can say the values must be unique. Okay, so like consider a dictionary which takes everyone's last name to their first name. And let's just actually let's do it this way. Let's have a dictionary that takes everyone's student number to their first name. Is it the case that that the one direction is unique? For every student number, you're going to have one name associated with it. If we reverse that, is the same thing true? Is there going to be one student number associated with everyone named John? No, right? So this is the same thing as like a function, right? A function has to be one-to-one before you invert it. So we'll say the values must be unique, right? That's going to be one thing that will solve this. But what? So our values are going to be becoming keys, right? So what other condition is on our values? Values must be immutable. Did we talk about this much last week? Let's talk a little bit about it now. If I have a dictionary, what would it mean? Okay, so if I have X's and I put 1, 2, 3 in it, what would it mean to like say this? What does it mean to key the list 1, 2, 3 to, let's say we'll key it to its sum 6. Okay, cool. What happens now if I then take X and append something to it? What happened to the key? Did the key also change? So remember, lists are references to things. So we're not actually putting the list 1, 2, 3 as a key into a dictionary. We're putting the reference to that list to a key in the dictionary. So if I say, look, 1, 2, 3 should go to 6, we can't really do that. I can say the reference to the list 1, 2, 3 goes to 6, but then we don't know what happens if that list changes, right? Once it mutates. Does that make sense? It doesn't make sense for us to make keys things that can change. Those things have to be static, right? So for this reason, we're not able to key by lists. Python's going to say, sorry, I can't do that. You can't key things that are mutable into me. For the same reason you can't key a dictionary into a dictionary. We can do something like this, right? Have a tuple or triplet. That's fine because tuples are immutable, right? So the keys of a dictionary have to be immutable because it doesn't really make sense to key something which can then change, right? So the second precondition here is that we must have immutable values. So we can do this two ways. We can just do a pure inversion, which actually would be pretty straightforward. So here's our answer dictionary. Let's just return it. And again, I just want to walk through this, our dictionary. For a key in our dictionary, we're going to get this value, oops, D. The value is going to be D, a key. And now this answer, I just have to say at value, you get key. So this one is going to be pretty easy. So let's try inverting it. Okay, A goes to 1, B goes to 2. If I put 3 goes to B, what are we going to get output? This is a good question to see if you understand. Pardon me? Yeah. So the outcome, how come I can't hit enter? Is the last key to be touched by this for loop is going to overwrite sort of the previous last key, right? So the second last setting of this is B goes to 2. And then on the last iteration, it says B goes to 3. So the last time it was just overwritten. Let's do something different where instead of assuming the values must be unique, we'll just invert it in such a way that the values can be lists. So I'll do it like this instead. So we have answer goes to empty. So we have to be a little bit careful about how now we key into this list. So to be clear, this is what I want to do. If I also have 3 goes to B, I want to say A goes to 1 and B goes to 2 and 3. I just want to collect all of the keys that went to that value. This is a little bit more tough because we have to be careful about how we key into this. So for key in D, I'm going to grab the value. And then remember, I'm going to do something like this. If the value is in the answer already, then I can just do something like append a key to it. And otherwise, it's not in the answer dictionary yet. So I need to create it. Something like this. Okay. Give this a go. Ta-da. Cool beans, right? So the lesson here is that remember, keys have to be immutable. Are there any constraints on the values? What can the values of a dictionary be? Can they be a list? Can they be a dictionary? Yes, like there are no constraints on the values of a dictionary. They can be anything that you want. Okay. Oh, I missed. There was supposed to be a slide in there that I missed. Let me pull it up now. Okay, so that's the sort of end of the housekeeping. We'll begin today's lecture, but I was supposed to show everyone this. If you are a person in this demographic, cool. Thank you. here. If you are a person in this demographic, there is a scholarship available to you. You'd be surprised how often these scholarships just go ungiven because no one's applied for them. I just sat on a committee where we had to give away 4 scholarships and only 2 people applied. So everyone won. So it may be worth it. It's worth up to $10,000 a year. If you want to scan that QR code, you can. Otherwise, I'll just throw this up on the EdSTEM after class. So worth $10,000 if you're eligible. Okay, so today's topics are going to be file input output, and then we're just going to talk a little bit about testing. So file IO. So I want to talk to you a little bit about the hardware on your computer. So we talked at the beginning of the year about like what a computer is, and in effect, it's some type of machinery that can do calculations on integers, like a calculator, that can read input and output, but it can also remember stuff. Like that was key. The fact that like we have these variables that we can store things in memory and retrieve from memory. Now, what I've just been saying memory as if it's like an amorphous thing, but it's not. It's a little bit more refined than that. Like when we're operating a computer, we're like literally moving our electrons around a circuit board. So there's like this proximal effect, right? If you're closer to something, you can travel to it more quickly. So this is true of the types of memory we have on your computer, right? So when the algorithmic logic unit, the thing that's doing the arithmetic, needs to write something down, there are like several types of memory that like get further and further away from it. And as the further and further away you get from the logic unit, the slower it takes to actually communicate with that memory. Like there's always 2 things that we have to worry about in like while programming. And many intro programmers fail to realize the second thing. Everyone's always worried about like, is my code fast in like sort of complexity? But you can sometimes write really slow code because of the amount of times you're asking to store stuff in memory. So there's also this notion of being like memory efficient, okay? So when you do a computation, like right beside the ALU is called cache. And it's like right beside it, it's super fast to access, but it's tiny. It's 256 kilobytes. That's thousands, whereas gigas is like thousands. Okay, so I have this L2 cache, super fast, super small. A little bit higher, or a little bit further away is the L3 cache, right? So these caches come in levels, L1, L2, L3. Still very fast, but less fast than the L2 cache, but 8 megabytes instead of 256 kilobytes, which is like a significant increase in memory. If you move up 1 level, you get to the random access memory. This is where actually Python is executing. I would say most modern computers have 16 gigabytes of memory. Who has more than that? Who has 32 gigabytes on their machine? Anyone? 64, 128? University of Toronto people brag more. But to give you a sense of like how fast memory is, or how quickly the cost of memory decreases. When I was in graduate school, like I was studying scientific computation, I had to get special permission to like run programs on a computer with a 16 gigabyte of RAM. That was considered like a special computer. So it's remarkable to me now that we all get to sit in front of these machines that like were considered supercomputers like merely a decade ago. Does anyone know why it's called random access memory? Like what distinguishes it from non-randomized access memory? So the old type of hard disk, we sort of have solid state devices now, which sort of changed the game a bit. But in effect, to find information on like standard memory, you have to do a little bit of searching, right? It may be on some layer of some disk. It's not straightforward, right? It takes some time to find stuff, suffice to say. In random access memory, it's set up so that you can access any bit of memory immediately. You don't have to search. That is to say that the access into that memory is random, right? You just go anywhere you want and you retrieve it. So it's a little bit more fast to use random access memory rather than the standard memory. Okay, but it's less memory, right? RAM is pretty expensive relative to buying like a 1 terabyte hard disk, which would be the next level up, right? So your computer probably has minimum 256 gigabytes of solid state memory. That's pretty far already from the ALU. Once you're writing to the hard disk, things are getting slow. And then on top of your hard disk is what we abstracted as like the cloud, which is like basically an infinite amount of memory, like to store stuff on the internet, right? So the two things that we need to consider here is that being closer to the logic unit is better because it's faster, but you get less memory. The further away from the unit you are, the slower the memory gets, but the more of it you get. Okay. The second thing that's relevant about these pieces of memory is that some of it requires power and other types of memory don't, right? So if you're executing a Python program on your computer and like the power went out and your computer didn't have a battery, let's say, the Python program it will be lost forever, right? RAM and the cache memory, it requires persistent electricity in order to remember anything. As soon as it loses its electricity, everything gets deleted. This isn't the case for like your hard disk, right? When you change something on your hard disk, some bit of memory is like physically changed using like a magnet, right? So that it's there forever. Now, the problem is when we're executing Python, we're in this memory, random access memory, and it's only 16 gigabytes big. And like functionally, you're not actually being allocated 16 gigabytes of memory. I think default, it's something more like megabytes. So consider the problem of like, suppose you're given like a terabyte of tweets, or what are they called now? X's? I have no idea. But you want to analyze them, okay? Well, okay, suppose your step one of writing that program is to load the terabyte of tweets into memory. What's Python going to say? No, I don't have room to put that in the RAM, right? And no one has that much room to put it in the RAM. Okay, so what does this mean? We give up? We can't do data processing on anything big? Well, obviously not, right? So what I have to do today is show you how to interface between the random access memory and the disk memory, which basically means I have to tell you how to read from files. But what we're not going to do from files is read the entire file into Python. That would be purposeless, right? We're going to learn how to read files one line at a time and process them like that. And this requires some thinking, right? Because it could be easy to answer questions about a file if we could read the whole thing into memory. But that's not what we're going to be doing. Okay, so when Python, or idle, launches, it gets allocated some space in RAM, which is possible to fill up, right? Very possible. This is a problem if we want to solve memory-intensive problems. Oh, and the other thing I failed to mention is, suppose you wanted to actually like save something. Suppose your Python program was calculating something important and you want to like remember it, right? So sometimes we'll actually want to have our Python programs write to a file so we can save the results of our programs. In either case, it's necessary to instruct Python to use the disk memory one level up. Okay, so here's a file, and I've just put in the new line characters. I've made them visible, so it's really obvious what's happening here. Because remember, we have all of these escape characters, which are instructions about formatting, which we can't necessarily see, right? We can't see empty characters. We can't see the tab. We can't see a new line. So here's a file. It's what a new line, wonderful new line, hello world. That's it. There's no new line here. Otherwise, there would be one extra empty line at the bottom of this. Okay, so this is going to be in a file called hello.txt. So to open a file, assume to be in the same directory where you're running, do the following. Now, directories are used to be something that computer science teachers could take for granted, but it seems that the file system abstraction has been lost. Because on your phone, if you want to find your photos, you go to the photo application, right? You no longer have a file system. So on your computer, right, you have like a desktop and you have folders. You can put folders in folders. When I say directories, this is what I mean. You can hear the word folder as synonymous with with directory. But what's important here is that where you have saved your Python file is where you should also save any files that you want to read into Python. They have to live in the same directory. I can tell you how to move to other directories. Okay, so here's how you do that. So if you just open a terminal or like a Python interactive mode and you import this operating system library, you can say operating system dot get current working directory. I think that's it. That. So this is where Python is looking for files. If I say open a file and I don't tell it where that file is, it assumes it's in its current working directory. Right. So if you're ever looking for where you're, if you ever get an error saying I can't find this file, you can always run this command in your Python, and it will tell you where it's looking. The command to open a file is just open. So you say open, you give it the name of your file, or you give it the name in a relative path, or you give it a name in an absolute path, which we'll talk. And then you have to tell it what you want to do with the file. So there's several modes, right? So sometimes we'll want to read from a file, sometimes we want to write from files, and sometimes we want to append to a file. Appending means go to the end of the file and add stuff. So here's how we can read from a file. I say file open hello.txt for reading. Maybe I should just actually do this. Do I have I'll have to create a file. So let's just do that. Okay. So I'm on my desktop. That's my current working directory. I'm going to touch a file. I'll call it hello.dat. Let's open it. And I'll just put, okay, what a wonderful world. Cool. Okay, so if I go into Python, I can say something like, I have a file and I want to open hello.dat for reading. There we go. It's open for reading. Nothing happens, right? Because we're just doing an assignment here. File gets now a reference to that open file. Okay, so I can now do things like say file.readLine, and it's going to read one line of the file, but it brings it in as a string, right? And what was the first line of our file? What a new line. So that's why that new line is there. So I'm sure you're getting a lot better with strings now after engaging and fighting with the grade scope, right? Because why these two things look exactly the same? How come they're not equal? Well, that's why I was going on about spacing. If you read a line again, we're going to get wonderful. And if you read a line again, we're going to get world, hello world. And notice that there's no new line there, right? Because otherwise there would have been a blank line in the last file. What do you suppose happens now if I read line again? We already read every line in the file. And I'm going to say this is one of these decisions that we had to make as humans. So it's arbitrary. So you can't really be wrong. So what would be good ideas, right? We're at the end of the file. I'm trying to read from it. What should happen in this case? How would I ever know I'm at the end of the file if I just started over again? I'm not saying that that's wrong. I'm just saying that sort of has that disadvantage. Any other guesses? Anyone from C programming here? Yeah, in C programming, you get the what would it even be called? It says end of file. It returns EOF to you if you try to read from the end of the file. We don't have that in Python. Python's really friendly, right? So what it does is you just it'll read empty string forever, right? It says you're at the end. Empty string, empty string, empty string, empty string, empty string, which is different than a new line character, right? And you could have an empty line and that would return new line, which is different than empty string. But that's how we can detect we're at the end of the file, by reading a new line. Now, we don't really have to worry about this because, as I said, we're just going to use a for loop, which more or less automates walking through anything enumerable. And of course, a file is enumerable. So if I open this file for reading, I can say for a line in the file, let's just print the line. And because I'm printing something with a new line character embedded in it, that's why we're getting these double spaces. But this is what we're going to do with files. We're going to open them, and we're going to walk through them using the for loop and do whatever type of processing that we need to do. Okay, so I've run this for loop, right? I've opened it at line 1. I've ran through the for loop. What do you suppose happens if I try to for loop again now? How many empty strings? Nothing will happen. I'm at the end of the file already. There's nothing else to walk through. This is an empty for loop. Okay, so if you want to walk through the file again, you have to open it again, right? So this is how we have to see a file, right? Because the file is too big to load into memory, we're not allowed to like have an abstraction in our brain where we get to see the whole file. A file to us is something that we get to read one line at a time, and we only get to look at it one line at a time. So effectively, a file to us is just some reference to what line of that file that we're at. And every time we read, that pointer gets pushed down one line, and eventually it gets to the end and where it stays until we reset the pointer by reopening the file, right? If that makes any sense. So if I then just open the file again and I try to do the same thing, then it's going to work, okay? So you get one for loop to execute for every one time you open the file. If you don't close your file after you're done with it, they're vulnerable to side effects, right? So without going into too much detail, the operating system has something called a buffer. And when you hit A on your keyboard, it doesn't necessarily rush and then type A. It's waiting to see if you've typed a bunch of other stuff. So it'll write all of that at the same time. The same thing will happen with the file. If you give instructions to write to the file, those instructions don't happen immediately necessarily. The computer is going to do it when it gets to it. That means if your Python program ceases to execute before the operating system has allowed this writing to the file to happen, there may be stuff missing from your file. When you close it, it tells Python is telling the operating system on your computer, I'm done with this file. Anything that you still have to write to this file, please write to the file. I'm done. Okay. My first job as a programmer, for the life of me, I couldn't understand why I was printing to the screen and seeing all of the results. I was writing the exact same stuff to a file and stuff was missing. And it's because I didn't close the file. Okay, so as soon as you write a file open, right, you're going to want to do file close, right? You want to get in this habit. As soon as you open, write close, but there's actually something much better than doing it like this. And it's using this with construct. I never use file open or close if I could avoid it. This is much better. So the advantage of this with construct is that it opens and closes your file for you. The other thing that it does is it really designates a spot in your code where you're doing file processing. So you have this sort of with construct, and inside with, you get to use the file, and outside with, the file doesn't exist. It's good to sort of compartmentalize your code in the following way. So we can say with open the file hello.txt for reading, and then we just give it a name, right? So I'm going to say as file, and then you can go ahead and do anything that you want with that file, like using a for loop. And again, it will close the file for you. It also, if something happens, if some error happens with reading the file, with actually handles that. So it's a little bit more robust than I'm giving it credit for, but I much prefer using this if we can. Okay, so let's just try some exercises using files to get used to them. So let's just write a function that counts the number of empty lines, right? Lines containing only the new line character in a file. So I'll just go here. We'll just borrow a hello.dat. So here, there's 1, 2, 3 new lines. There's a couple there. 1, 2. Okay. So here's a file. How many new lines does it have? Empty lines does it have? 1, 2, 3, 4, 5, 6, 7. Okay. So we're still good? Jeez, that's weird. Okay. So def foo. So what do we need to do? Counts the number of empty lines. Okay. So this is going to be some type of file. And we're going to count the number, return the number of empty lines in file. Okay. So there are two ways that we can actually write this function. When dealing with files, who opens the file now? This is the question. Will the function open the file, or will the person calling the function open the file? And it's like, I don't know, both are valid. So let's do it in two ways. So the first way we're going to do it is foo opens the file. Right? So this function opens the file. So this is not going to be a file, but it's going to be file name. Okay, we'll say that this is a string. Right? So that's the first way we'll do it. So return the number of empty lines in the file. Well, I'm going to have to accumulate something, count something. So I'm going to start an answer from 0 and then return it. And then I need to open a file. So it's something like with, geez, I already forget. It's open. Syntax, yeah. With open file name for reading as, and I'll just call it the file. Now inside this with control structure, I'm now allowed to use the file. And so I'm going to say for line in the file. So I have to check if the line is empty. So what was it? How can I check if this line was empty according to our definition? Yeah. If the line is a new line, right, then it's empty. Then it's empty. And we just want to increment this by 1. Yeah? Okay, so let's see if it works. Okay, so I need to call foo, and I need to give it a file name, hello.dat. And I'm not going to hit enter because I need to know what to expect. So I'm expecting 3, 5, 7. Perfect. Okay, what did I do wrong? Did I save it? Oh, yeah, maybe. Okay, let's try again. Oh, okay, I didn't save the file. Cool. Good call. Okay, so that seemed to work. Let's add some more lines here and see. I'll take that one out. Cool, 10. So it seems to be working. Now I'm going to show you something else. So here, where's our hello.dat? Here's hello.dat. Let's put it in a folder called Drake, in a subfolder called sucks. Oh, well, just believe me. I'll show you. This is the peril of having to do this double zoom. Okay, so I made this directory called Drake. Right, and this is how it looks like. I think I have this tree command. Yeah. So Drake is a folder. Well, yeah, with a subfolder called sucks, with a file in it called hello.dat. Now Sandbox is sitting in the desktop. Right, so how then can I call it now? So I want to do something like this. Where am I? There we go. Okay, so I said we can find our current working directory like this. Whoops. So I'm on the desktop, which is, I'm pointing at something you can't see. So we can always give what is called a relative file path. So I know I'm on the desktop, and I know the file that I want is in a folder called Drake, in a subfolder called sucks, and the name of the file is hello.dat. Right, so you can file names also work like this. I can do the opposite, right? If you suppose that my file wasn't inside directories, but outside directories, like suppose I swapped it, that this hello.dat was on the desktop and my file was two folders deep. That says go back a directory, go back a directory, go back a directory, and then you'll find it from there. You can also do something where you give the what we call the absolute file path to a file, where you like start at C, or like your hard disk is like the top level directory, but we don't really do that. So these relative file paths work well enough. Okay, I should show you what happens if you like try to give it a file name that doesn't work. Right? It says we can't find, like this file doesn't exist. Right? So keep that in mind. Okay. We've done this. There's the answer. So there is a doc hint that we can use, but it's not default put into the system yet. I think it's coming. It was supposed to be here already, but in any case, if you want to provide a doc hint for a, oh, we didn't do it the other way. Apologies. Okay, so now I need to do this again, where user opens the file. Okay, so instead of being a string, this is going to be a file pointer. We can just leave it like, I'll just call this a file pointer. So we no longer open the file like this, but we can do everything else the same. Or I'll call this the file. Okay. So now I'm handing to this function like the file pointer instead of like a name of a file, and we can now call it like this instead. So here's Python. I need to get a file, which I think I put in. It's still here. Hello.dat. I need to open this for reading. Perfect. Okay, so now I say foo, and I give it this file, which is already open. It gives me a response. And now I have to close the file. Okay, perfect. Let's do some more. So there's the answer for that. Suppose you want to read the numbers from the following file into a list, right? That may be something that we want to do. We have to remember when we're reading from files, like we're always reading strings. In fact, like we have this notion of like input output that Unix uses, where input to a program is always going to be text and output from a program is always going to be text. It just simplifies everything to say text in, text out, instead of having to type it in some way. So just remember that when you input anything, it's a string, and we're going to have to convert that string into some other type if that's indeed what we want. So let's just do it. Okay, I'm just going to make a folder called a file called numbers.dat. Let's just code it. So here's my old phone number in Canada, 905-684-1821. Adjusting to new phone numbers is super hard when they change the cadence. Okay, so we want to read the numbers in to a list. Okay, so let's just write a function foo. We're going to return a list of ints. We're going to take a file path, which is a string, so we will open the file. So let's have an answer start from the empty list, and we'll just return the answer when we're done. So I can say again, with open this file path for reading as, I'll just call it the file. Doesn't really matter what you call it. Then I'll just say for a line in the file. So line is going to be a string, which in the first one, it's going to be 905, and then 684, and then 18, and then 21. So to answer, I want to append the integer casting of this line, right? I have to convert the line to a string. Now, there are some problems here. Oh, here? String. Okay, thank you. All right, so as I said, the first thing that we're going to read is this, 905 new line. Remember? So is there any problems doing this? Potentially? You say yes, there's a problem. You guys should be a little bit familiar with converting strings of numbers to numbers from A1. Did you discover anything friendly about this integer cast routine? It doesn't care about space. Oops. It doesn't care about space. It doesn't care about escape characters. You can't do something. You can't put like spaces in here. Like now it doesn't know what that means. But this integer casting is really friendly, right? Other languages wouldn't give you this. So this is fine. This is fine because integer casting routine or function is smart enough to strip stuff that we don't want it to be. Okay, so let's try to give this a run. Whoops. Oh boy, freezing. Right, so I foo, and I have to give it a file path. I guess that's just numbers.stat. And I should get a list of numbers, which is my phone number. Perfect. Okay, so this is like a really common use case of having a file, like walking through a file consisting of numbers and converting them in. Okay, so here's a more complicated one. So here's a CSV file, comma separated values, and the file is going to have bands in it, and we're going to know the rating of the band and the number of plays of the band. So like the Wiggles has rating 2, and they have 1,849 plays. So what I want to do is write a function that, given a file like this, finds the highest rated band. What's the highest rated band in here? I recently changed it because of the Eras tour. It's Taylor Swift. She has an 11. That's the highest rated band. Okay, so when we write a function based on this file, we should expect to get Taylor Swift as a result. So let's start writing it. So I do have that file saved here. So I have it in lecture 5 oh, I have to change this to 11. So it's in a directory called lecture 5 in a file called bands.txt. So this is the thing that we're going to want to open and process. So we can keep most of this actually. So what do we need to return? Okay, so a string. We're going to return the name of the highest rated band. We don't really know what we're returning yet, so I'll just do this. So I still need to open the file. Let's keep that. Let's call it the file. So for a line in the file, well, let's get rid of that too. Okay. So we're going to open the file. This is the file. What's the first thing that we should do before processing anything? Huh? Well, I don't care about this line though. That's a special line, isn't it? Called the header, where it doesn't actually contain any information for what we're trying to do. So what I'm saying is I'd like to skip this one. I don't want to process this line. How can I skip one line of that file? Exactly. So I can say the file dot read line, and I'll just let it read one line of the file whose effect is to move the file pointer down one line. And I'm not going to use it for anything. I'm just going to let it sort of evaporate. This is a perfect place for an inline comment, right? This skip the header. Perfect inline comment. This is exactly the type of place where we'd want to write something like this, because otherwise I have a single read line in my code, which seems kind of out of place, right? So now it's like, no, this is deliberate. Don't remove it. I want to skip the header. Okay, so we've skipped the header. Now what I want to do is for a line in the file, and I want to do now what my colleague there recommended. Split this into 3 pieces. Who remembers how we can do this? We did, yes, sir. Yeah, we want to split this on comma, and that's then going to separate that line into band, rating, and number of plays. Cool. Do we ever use this value in this function? So I suppose I'll just write something here. Return the return the name of the highest rated band. Is number of plays relevant here? Yes, sir. Perfect. That's my colleague up there said no, so therefore use an underscore, which is correct. Right. So since that's we don't want that, we don't need it. And in fact, if you had warnings set up on your idle, or some of our IDEs would actually complain to you saying, hey, you defined a variable name and you've never used it. In this case, like, I don't want to use it. Like, I'm just using it as an unpacking variable. So using an underscore is what we call an anonymous variable. You're saying, I don't care. This is just here as a placeholder. So ignore me. Okay, so we're going to get the band. We're going to get the rating. What's true about rating at this point? We're reading it in and its type is what? String, but we need it to be integer. Okay, so how can I change rating to integer? I'm just going to say rating is integer rating. Strictly speaking, actually, as long as we were assured that that second position was a string representing a digit, I don't actually think we need to convert to integers because we can still do the string comparison. But this is a little bit safer. Okay, so we can look at every line in the file. We've pulled every band. We've looked. So I've looked at every band and rating. So let's just do a print just to see what it is we've accomplished. So I can say this is the rating and this is the band. Let's see if we can do that. So I'm going to call foo. I'm going to give it the file path lecture 5. And then this was called bands.text. And then it should print out all of the ratings and bands in the file. Oh, that should be line.split. See, this is why it's a good idea to do some of these tests. Does that seem correct? Yes. Cool. Well, that one is here. Return. Are you laughing that we found that Drake is ranked 0 after listening to his song once? Right. That's the number of times it took. Okay. So I managed to look at every rating. I've managed to look at every band, but we still have to figure out which one of these bands is the highest rated band. So how can I do that? Yes, sir. Sure, let's do that. So we can have, I'll say something like current highest rating. Then I can have something like current highest rated band. So I'm going to set that to empty string. We'll think about what this has to be in a second. Okay, but if I have those things, then I can do something like here, saying if this rating is bigger than the current highest rating, then the current highest rated band is this band. Make sense? And the current highest rating is this rating. Savvy? Okay, so, and then what I return is the current highest rated band. So it's all that's left to determine is what value we should put in at line 6. So what's the objective here? So the first time this loop runs, the if statement has to trigger, right? Because the first band that we look at is going to be the highest rated band, right? Just by definition, it's the only thing that we've looked at. So how can we assure that this is going to trigger? What value do we put in at line 6? Yes, sir. Okay. That would work. Float negative infinity. Like literally any value is going to be bigger than that. Supposing that the lowest rating is 0, which is a good assumption to make, because if there was lower ratings, Drake would have it. So let's consider Drake lowest rating 0. What's another option we had then instead of minus float infinity? -1. All right. Although yours is more robust. Yours would allow me to have negative ratings. But the point is 6 had to be set to a value so that at line 15, that if statement was guaranteed to trigger at least once. Right? Now, we could have done it in such a way where I I did one iteration and put that into here, it would have made the code twice as long, right? Because I would have had to do all of this once and then do the loop, right? So I'm trying to train you to write less code by showing you some of these little clever tricks. Yeah. Can I set line 6 to none? Like this? Yeah. Well, but like, does none have the property that it's less than every number? Are we even able to compare none with the number? We can try. Is none bigger than 0? Not supported. You can't do comparisons among different types. And none lives in a type all by itself called none type. It has one member and it's called none. So this one has to be -1. Okay, so before I brag too much, let's see if this is actually working. So foo, remember, we're expecting to get Taylor Swift back. Lecture 5 dot slash bands. Was it capitalized? No. Bands.text for reading. Oh, wait, what am I doing? No, this bands.text. Why? Oh, I put 62. Okay, 100, right? Coldplay. What? Why is it now saying Coldplay? Oh, because I changed Coldplay. I have to respect the queen. Taylor Swift. Great. One of our admin was trying to get tickets for her show, and she had like all of us log into like separate computers, and she almost had an anxiety attack when she got them. But she got them. She got them. So she's off to see the queen. Okay, let's do the other one now. Called worst band. This one's going to be way easier. Okay. Okay, that's perfect. Okay. Shad is better than Drake. Oh, what else do we have to do? Okay, so there's the answer to that one. Okay, so here's some exercises that I'll give you to do at home. So suppose you have like just an arbitrary CSV and it has an arbitrary header. Suppose the header in this case is like name, grade, and age. I want you to write a generic function where it's just called most. And you give me the path to a file and I give you an attribute. So I'm saying, find me the largest among the lines, maximizing in this case, maybe like age or grade or even name, right? You can try to find the person whose name is ordered greatest by the lexical ordering. Okay, so here's one that I want to do. How much more do I have of this one? Let's see. Okay, we'll do one more. Okay. So this was from, I think, exactly a year ago, where A1 for my students was to take a Sudoku. They did Sudoku as their first assignment, effectively. And this ended up being a really nice example to use all year long. So I want to sort of borrow it because I can show you how to write a dynamic program to solve Sudoku. It's actually not that difficult. And then I actually have a really nice version of Sudoku, which I wrote with tkinter. But the first task that we gave them was to read this from a file, but it was kind of abstracted. So we want to read this Sudoku board into like a list of lists. That looks like, do I have it? No. So I want a list of lists from this Sudoku board so I can process it. So the list of lists, the first list should be 6, 8, 5, 1, 3, none, right? So when there's like nothing on the board, I'm going to put none in it, right? So I want to write a function which takes a board that looks like this and to return a list of lists where empty spaces are designated as none. Okay. So I have a lot of boards here and here. So let's look at board 3. So here's the board. Let's call this read board. We're going to take a file path. And what I'm going to do is going to return a list of things that are either integers or none type. What? Maybe it doesn't like it. Oh, none type. Still doesn't like it. Or none. Okay, I think that's a little bit better. Yeah, so this is saying I'm a list of lists And the thing in me are either integers or none. Okay. Read a Sudoku board. Okay, so we're going to get a path. So the first thing, okay, so here's my board. The board is going to start off as empty, and then I'm going to return it. Now what I want to do is say with open fpath for reading as, call it file. Oh, doesn't like that, the file. And then I'm going to walk through it for a line in the file. Now we have to be a little bit clever about this. Okay, so there are clearly two types of lines here. Lines that include vertical bars and lines that don't. So the first thing that we have to notice here is if the line doesn't include a vertical bar, we should skip it. Like I don't process this line and I shouldn't process this line, yeah? Okay. So, okay, let's try to be, so I need to have a row that's going to start up as an empty list. So I'm going to grab a line from the file. Supposing it looks like this, I want to do something like, we have to be clever about how we do this. All right, so if, okay, I have to walk through each character in the line. So for X in line, what do I want to do? If X is a space, then to the row I want to append none. Elif, is it elif? Or, yeah, it's elif. Elif X, how do I want to do this? If X is in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then we know it's a digit because it's still a string at this point, right? So I pulled it out. So if it's a space, it's none. If it's this, then we append to the row the integer version of X. And otherwise, don't do anything, right? Don't do anything, right? Like if it's this vertical bar, just kind of skip it. If it's one of these, just kind of skip it, okay? And then once I process a line, I want to add to the board this row. And let's see what we got, okay? All right, so this is a problem that I was seeing in A1 while talking with people in the help center, is that we asked you to parse a string, and there are two options, right? You know how we said like it's a number, then a blank, then a number, then a blank, then a number. How many ways can I hand you a string that's formatted incorrectly? An infinite number of ways, right? So you can either try and write an if statement to check the infinite number of ways that that string is wrong, or you can write one if statement to check if the string is formatted right. Right, so you definitely want to check that if it's right, because it's impossible to ask, is this wrong in this way? 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 Right, so you ask, is this formatted the way that it needs to be? No, well then it's not formatted the way that it needs to be. Right, same for here. Right, because a lot of people really struggled with this, and it ended up being two loops. Okay. Where am I? Okay, so let's read in my sandbox. I'm in the right, where am I? Yeah, desktop, okay. Read board, it is in lecture 5 in something called boards in a file called board3.txt. Okay, that's looking pretty good. I should have wrote a pretty printer. It's looking like way more than it needs to be, though. So have I made a mistake? Have I appended too much? Oh yeah, that shouldn't be there. That should be back one. Let's try again. Still seems wrong. I have one list of one. What am I doing wrong? Pardon me? Yeah, oh, this should be in the for loop. Because every line is one row. Okay, yeah, I moved the wrong thing. Okay, let's try this. Okay, that's looking better. although we have these empty lists here, and we have exactly 2 of them, what happened? Well, those empty lists are happening here because I said, convert this, find all the numbers and spaces in here and convert them into numbers or nuns. Well, how many numbers or nuns were on that list or in this row? None, right? So actually I was supposed to skip this row and this row. So how can we skip these rows? Yeah, you could set a condition where you encounter dashes. We can count the lines and skip line 4 and 8. Like there's like a dozen ways at least that we can skip these, but why don't we just say if the row is empty, then don't add it, right? So we got to try to use this information we already have if we have it. So actually I just say if row, right? This means, remember, this means yeah, if row is not equal to, this is the Pythonic way of asking if something has something in it, if row. So I just add that there. Now it's working fine, right? So this was one of the main assessment pieces for my students last year. Okay, so we're not, I think once we show you the solutions to your homework, you may do one of these, or like, oh my God, this was much easier than, we're not trying to punish you. I don't know how to put this delicately. Like, if you're finding that your code is way too complicated, it probably is, and you should delete it and start over again, right? And I know how, like, but I poured my soul into this code. How can I delete it? During my PhD thesis, I was given a problem to solve, and I worked on it for 3 years, and I wrote thousands of lines of code for solving it. Then one night at 4 a.m, I figured out a different, better way of solving that problem. And I deleted 3 years of work and started over again, and what I produced was much better. Normally, it takes 3 tries to write any software that's working properly, right? You write a draft first, right? So try not to get too attached to your code, right? Because what happens is you just try to add to it. You keep adding to it to fix stuff. And like the more stuff you add, it's going to get worse, right? So sometimes the best strategy is to give it another try, even though I know that it may hurt. Okay, so that was good. Writing to files. Okay, so I said there's like several modes that we had. One of them was reading, and that's when we can't store the information we want to process in memory. Another one is writing. Now, this comes with a warning. This is the first time we have given you a command which can destroy something on your computer permanently. If you write to a file, the Python is going to create a new file with that name. If the file already existed and you asked for a new file to be created for writing, the old file is overwritten and gone. Delete. I don't even want to say delete it because you're used to deleting stuff and it showing up in your recycling bin. If you overwrite a file, it's gone forever, right? So this opening a file for writing has a destructive property. Okay, so I'll show you what I mean by this because this is very serious. Okay, so here's my board 3. Okay, and we just wanted to open it for reading, right? So let's try this. So I'm going to grab that file path. Okay, so I'm going to open it for reading. Whoops. Did I forget a comma? Did I forget a comma? Maybe I don't want double of these. Okay, opened. Okay, opening, that's fine. So far, nothing wrong. Let's now open this for writing. Ready? Gone. Deleted. Forever. Gone. Unrecoverable. Not in your recycling bin. No undo. Well, okay. I would technically be able to undo this because only because oh no, I can't undo this. Oh yes, I can. It's in the buffer of VS Code itself, right? So you may get lucky if somehow your idle remembered enough to undo it, but really you got to be careful. You can permanently delete stuff. So whenever you're working with the write command, just make sure to duplicate everything in your directory because you really, stuff will disappear. Okay, now that we're here, let me just show you some stuff about, okay, so I'm going to go back. I'm going to save this. We'll do the destructive thing again. So here's my file. I've opened it for writing. It's gone, just gone forever. But now I can do stuff like I can write to the file. So that says I've written to characters by, right? So where is the, how come stuff isn't showing up in this file? Well, because Python, like the operating system is being lazy. It's like, I don't know, you may want to write more, like opening a file is really hard. So I'm going to wait until you maybe write more stuff. And then when you're done, then I'll open the file, right? So as I said, so here we've written to the file, it's not there because we have to close the file before the operating system is going to put anything in it, right? So that's really the lesson of today, right? Reading from files isn't that, like basically what I've shown you how to do is use a for loop to walk through a file, right? And you already know how to use for loops and walk through stuff that are strings. The writing is the thing that's new here, where you can get a persistent memory. So please don't delete something that you need, because I won't be able to help you recover it. And don't forget to close, or you won't see what's in there. If you want to be extra safe, you can always open a file for appending. This is an instruction to write to a file, but to the end of the file instead of deleting everything that's in it. So in summary, we can read from strings. For summary, we can read strings from files one line at a time. A file pointer is moved down the file every time that we read a line, which is automated by the for loop. Therefore, if we want to read a line twice, you have to open the file again. You can't push the pointer back up. You only get to look at these things one at a time. And it is a mortal sin of programmers. Like there's something called read all, where you can like take the file and like read its entire contents into a giant list, which simplifies logic, but totally defeats the purpose of using a file, right? So try not to get tempted to read the entire contents of the file into a giant list because it's easier for processing. That's not going to work when the file is super big. Okay, so just a short lecture to wrap things up today. Maybe I should pace a bit. That would warm me up. Freaking freezing. Okay. Testing. So we want to be good programmers who write correct code. And one of the ways that we can write correct-ish code is to test it. So like, if you're working at a software company that has like an existing piece of software, they've been writing hundreds and hundreds of tests for this software, which they can run by hitting a button. You can actually get hired at a software company as a QA analyst, quality assurance. And their job is to basically write tests. Now, if you work at a company and you're like, hi, I've implemented this new feature, I want to put it into the software, they'll say, okay, but first, we're going to run all of the tests to see that your addition to our software hasn't broken anything, right? So that's how these things get done. And once you put your code in and it passes all of the tests, then it's allowed to be shipped. So I just want to talk a little bit about testing and the philosophy. This is not something that we're really going to go into very deeply. You should just be aware that testing is important, but I don't think we're ever going to give you a direct assessment item. And if there's if it's on the exam, we'll be like one question. Okay. So I've always been trying to include these doc strings. You are obligated to include these doc strings, and a couple of these doc examples, right? Usage examples. What I didn't tell you actually is that by doing this, you've already set up testing, because I can actually instruct Python to look at your doc string and run these examples. Like what you're saying here is you're actually making an assertion. Like by saying here's the example usage, factorial. If you call factorial of 3, you'll get back 6. Well, I'm actually asserting here that factorial of 3 should be 6. That's a test. I'm asserting here that factorial of 0 should be 1. That's a test, right? So I can show you how Python can do this, and it will be be informative. Okay, so let's go back to here. I'm just going to write a factorial function. It's going to take x. It's going to be an integer. This is going to return an integer. I'm going to put a couple of docstring examples. Factorial of 6. That's too big. 3 should be 6. Factorial of 0 should be 1. Factorial of, I think 6 is 720. Let's check. 6 times 5. Perfect. Okay. So I'm going to implement this. I'm going to ask you how you feel about it. I'll call this n. Okay. How do you feel about this factorial code? Ship it. Works perfectly. Okay, well, why don't we run the tests on it to see if it works? Okay, so I'll show you how to do that. Huh? Yeah, so that's probably wrong, right? This answer equals 0, but let's just confirm. Okay, so I'm going to do something okay, so I have access to my factorial function. That's fine. So I can do something like I'm going to import test mod, which is a library. What? Oh, doc test, sorry. Import doc test. That's better. And now I can say doc test this module and be verbose about it. Verbose is to use more words than necessary. Yes, thank you. How do you spell verbose? No, I don't put quotes. You would think that I, among all people, would know how to spell verbose. Okay. So here's the results of this testing. It's saying I'm trying to execute factorial of 3 and expecting 6. And I didn't get that. I think, did I spell some stuff wrong here? Let me try this. Fact. Let's try again. Whoops, did it again. Import doc test. Actually, let me just put that up here. Okay, doc test mod. It's saying factorial at 0 failed. I expected to get 1. I got 0. I'm going to try factorial of 6. I'm expecting 720, and I got 0. So that failed, right? So this is basically saying failed. I don't have to be verbose. I can also just say this. And it's just going to say, I failed. Okay, so I think my colleague over there, realized that if answer starts at 0, if I multiply 0 by anything, what do I get? 0. So is answer ever moving? No, it's 0, and then I multiply it by x to get 0. Okay, so what should answer be? Cool. Okay, so everything's working perfectly, right? So let's check our testing apparatus, and wait, it's still broken. Okay, so why is it still broken? Because the range starts at 0. I just did the same thing. So now, how can I fix this? Yeah, I want to start from 1. And I want to go to n plus 1, right? Because it's right exclusive. Okay, so this should work. Ta-da. Okay, so by diligently including usage examples in your doc tests, you have also implemented testing, because you just have to now call this test mod, right? So that's cool, right? Because you can go back to your old programs and just run this, and it should validate everything for you. This is not really how we do testing in Python. There are much more sophisticated tools. The true purpose of this tool is actually just to check your doc strings before they go out to the world to make sure that they're correct. But we can still have this usage for them. Okay, cool. So here's my corrected version. Okay, so the question now becomes, like, what should we test? How do we get good coverage? And the answer is, like, I can't really give you definitive rules for like when you have enough tests. It's not even the case that more tests are better tests, because more redundant tests are not better. You're just doing something slower. So this is more of an art. This is why you can get hired as a QA analyst, and people just have a knack for it. Here's some guidelines, right? So when you're testing your code, you want to test typical cases and edge cases. And edge cases are the things that we're mostly interested. What do I mean by an edge case? Well, these are, you have a data type like lists, and some of those lists are strange, like the empty ones. So we call the empty list an edge case, right? Because if it's one of the edges of that data type. If you're using integers, 0 may act strangely. You also want to sort of test singletons of things, right? So maybe the list of exactly one member, or a string of exactly one character. You want to test for correctness, right? So don't write a bunch of tests presuming that the user has input something wrong, because there are an infinite number of ways the user can input something wrong. What's our philosophy in Python? Blame the user, right? If it doesn't work, it's because you used it wrong, right? Provided that you've delineated exactly the correct usage. Okay, so we are all working on under the presumption that our doc hints, our type contracts are being respected, right? We don't check that. So don't check for violations of the contract, and don't check redundant tests. What we're doing here is string comparisons. And you may have learned that string comparisons get a little bit tricky when you're doing testing, because we need to have things done exactly. And in particular, white space is our enemy when doing string comparisons. So if I wrote the identity function, just a function, foo x, return x, right? It's the most trivial type of function. This is going to fail if you run it through the doc tester, because you included a space, right? The empty list, right? You have to put there what Python would print. That's the empty list, but it would print that, right? So even though this is kind of strange, because this is equal to this. Okay, so when we do this type of comparison, it's called a string comparison. When we do equality testing, this is called a unit testing. We're not doing unit testing. We're just doing string testing, which is a little bit easier. Okay, make sure that you have a comma and then a tailing space in your list, because this is how Python prints them. If you don't do it exactly, it's not going to work. Also, tailing space here is going to break things. Right, so this is going to cause the doc test to fail. And this is going to cause the doc test to fail because we don't have the spacing in there. So warning, we are doing string testing comparing printed output, and will not unit test, which is comparing values. The output must match exactly. Is this going to work? Well, if I print 1.0, what does Python print? 1. Right, so this doc test is going to fail, right? Because this needs to be 1.0, not 1, even though 1 is equal to 1.0. This is one of the deficiencies of the string testing. So in floats even become more of a problem, right? Because we don't actually get to work with real numbers. We're working with an approximation of real numbers. So if you wanted to put identity pi, like how many digits of pi should you include? As soon as we introduce floats, everything sort of gets really, really complicated. So I'll show you an answer to this in the next 10 minutes. But suppose we were given the following function. How could we gain confidence in its correctness? Okay, so I'm going to write, and I want you to demonstrate. I want you to tell me some tests here. So I'm going to write the power function. Power. Base exponent. Okay. It's going to return an integer. I'm going to return b to the power of e. Okay. And I'm going to write a piece of Python code that you're going to understand at the end of the year, but probably not understand now. And I'm doing this on purpose. I want to write something that like you're not able to interpret because I want it to be black box. So here's how I can do this. This is E times the power of BE minus 1 if E else 1. Okay, and we have a precondition that E has to be bigger than 0. Okay. So I am claiming that this is a power, that this is going to work. You don't believe me, but all you're allowed to do is like ask me to evaluate this. So what test should I do to give you enough confidence that this is actually a working function? Let's go back to the checklist. One of them was typical case. So I don't know, like 2 cubed should be 8. And if it's not, you've done something wrong, right? What about an edge case? Pardon me? 0 to the power of 0 should be what? How did I define it? Yeah, I think I defined it as 1. Python defines it as 1. Again, mathematicians don't at me. It's just the way that it is. Okay. What else? What about 1 and 0? All right, that should be 1. Oh, sorry, E greater than or equal to. The power can be, I just don't want to have negative powers. Yeah, sorry about that, but you would have been correct and are correct, actually. This enough, you reckon? What else would you want? Like there's other stuff that we can do, like the power of 7 to 1. Right, that should just be 7. 1 to anything should be 1. Like what about stuff like this? Should I do like power of 2 and 4? Yeah, this one is redundant. Like this isn't really adding anything to the one before. Okay, so let me try and run this then. Expected 0 got 1. Okay, so I did make a mistake. That's the purpose of this. Expected 1 got, hold on. Power of 2 and 3. Am I? Whoopsie, that should be the base, not the exponent. Let's try again. But this is the point of testing, right? Like I knew that I got it. Okay, so now we pass. So this sort of works, right? And so effectively all this says is this, right? A to the power of B is equal to A times A to the power of B minus 1. That's the mathematical definition of powering, where A to the 0 is 1. Okay. So yeah, here's all the ones that we had. These are like a 0, a unit and a 0, a 0 and a unit, typical and unit, and typical and typical. How much time do we have? Okay, so here's one to do at home. Like write doc test for the following function and implement it. This is easy. Like just write a maximum function, right? Like how many tests do we need? Well, let's just do this one actually. Yeah, R max, X and Y. This returns the bool. Right? Let's just say this returns X greater than Y, but like we don't care. Like we're not looking at this. Like how many tests do we actually have here that are non-redundant? Well, this is all I can think of for this. Like the numbers are the same. The first is smaller than the second. The first is bigger than the second. And probably anything else is redundant. Maybe we can try some of the infinities. I don't know. Who wants to disagree? Oh, sure. Let's do this. Yeah. So we can use negative, but I don't really see like that it being different. Like it's just just a different number. Like we could put negatives, but I'd argue that like anything else in addition to this is just going to be redundant. Cool. Okay, this is a slide I have to update every semester because every time they do any change to Python, I get different results for this. But this just drives my point home more. Be very careful with sets. Somehow sets with numbers seem to order when you print them. And if they don't have numbers in them, who knows how they output, right? So, for example, here's a set with numbers and it orders itself. Okay, here's a set A, B, C. Now, to say that they're ordered is kind of misleading because sets don't have order, but it is relevant for when we're doing these string comparisons. So here's A, B, C, B, C, A. Sure. Let's move this B into the front. So see how it's just sort of like randomly permuting the ins. There's a reason for this. It's because sets are unordered, but this is just a little bit annoying when we're doing string comparisons. So just note that like in your doc string, you can do any arbitrary number of like Python commands that you'd like the same thing that you do in the REPL. So this is like a valid doc test. You can say, compare 3, 1, 2 with what comes out of the identity of 1, 2, 3, and the outcome should be true. So in this case, I'm just asserting things about a quality. You have to also be careful with dictionaries because technically a dictionary is just a set of key value pairs. You can also do stuff like this. I can say A is 2, B is 1. The identity of A plus B is 3. Write doc test for the following function. So this is a good one to do at home. You've all taken calculus, right? No. Oh, you all know what a parabola is? You all know what the quadratic equation is? Okay, that's enough, right? So I'm saying I'm going to give you a parabola, and I want you to tell me where the parabola has its minimum value, right? Its minimum value is where its critical point is. But there's no preconditions on this, which really messes with things, right? So if A is 0, then there's no answer. If A is 0 and B is 0, then there's an answer. So there's like tons and tons of edge cases for this problem, which is why it's a good one to consider when you're at home. There's an answer here. The last thing I want to leave you with is, suppose you want to write like 100 doc tests. You don't maybe want this to be in your main file. You can write all of these things in an external file, like texting.txt. The whole contents of the file is basically what you'd put in as a doc string. Don't include the triple quotes. And then you can call testmod on. You can say doctest.test this file, the one in testing.txt, and try to validate everything in there. Okay, so there's some exercises I've left here for you to do. You can look at those at home. So you should always write these doc tests in your functions to be a good programmer. We've been doing that anyways. This concludes imperative programming. Okay, so next week, we're going to start object-oriented programming, right? So we're basically done the first module, and then you'll get a week relief. And then after next week, we're going to launch A2, which is going to be more about design than programming, right? Because that's what object-oriented programming is about design. Help Center's open. Go use it. Good luck. See you next week. Bye, chat. Hello. Yes, I figured. Yeah.
Have you gotten me out of this shit yet?
Pardon me?
You were going to contact some people and get me out of it.
Oh, so we discovered that no one even asked me permission for your son to be here, which they were supposed to. Yeah. So like, if you just like,
it gets harder.
functionally speaking, no one's checking that you're here or not.
Yeah. I'll
So, like,
to you. I know what it's like.
If you don't come, I'm not gonna tell them. They're never gonna check that. I've actually asked them to check those before because someone stole something and they said we have no access to them. So it doesn't matter for right.
This subject gets hard.
Oh yeah.
He says he knows it.
Pardon me?
He says he knows it.
Well, yeah, so this is technically an intro programming course. So if he has intro programming, yeah, for 5 weeks maybe. Does he know object-oriented programming? it probably is gonna get harder, but if not, you should just take the EC6, EC7, so, yeah.
Thank you, sir.
But yeah, no worries.